Good morning or afternoon, wherever you're located today. Thanks for joining us. This is the Online Technology Forum. So in this forum, in this series, we're talking about people, processes, and technology. We spend a lot of time on those three areas, and this forum really allows us to focus those people and processes. Well, it allows us to discuss the technologies that allow us to focus those people and processes. In this series, we partner with the operational community and industry solution providers to go over those pieces of technology and how they apply to the operational community. So in today's session, we'll be talking about hyperspectral imaging as part of a layered explosive detection capability. So we're excited to have the group we do. But before we get started, I wanted to give some basic platform instructions for everyone on the call. So on the right-hand side of your screen, if you're on a desktop, you'll see a menu. If you're on a smartphone, you'll see at the bottom of your screen some menu options. We're not using the hand-raising function. We do encourage everyone on the call to pose questions as we go through the content. If you're on a desktop, again, on the right-hand side, you'll see a question button. Please post questions at any point. We do have some built-in Q&A breaks throughout the presentation. We'll field those questions to the presenters. If you're on a smart device, again, at the bottom of your screen, you'll see a question mark. Please click that question mark and post any question that you might have throughout the presentation. So again, we want to get to as many questions as we can. If we can't get to those questions on the forum today, we'll try to follow up with you in the coming hours and days. So again, thank you everyone for entrusting us with some of your Thursday morning here. So we'll start by introducing our speakers. So we'll go around and have them give a brief introduction to themselves before we start diving into content. So if we could, we'll start with Sergeant Smith.
Good morning, everyone. Robert Smith. I'm with the Sheriff's Office in Charleston, South Carolina. I'm assigned to the bomb squad and a canine handler. I have a little over 29 years on the job and extensive time in the bomb squad and handling a bomb dog itself. I'm also an instructor at New Mexico Tech. And besides some of our local sports venues, I've had the privilege of working some NASCAR races, Super Bowls in Atlanta, and now part of our template here today is preparing for our second PGA championship on Kiawah Island the last 9 years. So thank you for your time.
Thank you, Sergeant Smith. Dave?
Good morning. I'm Dave Caudle, Business Development Manager for ChemImage. My background is 12 years as a U.S. Army officer in the Infantry and Special Operations Forces, and 4 years working with hyperspectral imaging technology for use in military and law enforcement applications.
Thank you, Dave. And Dr. Nelson?
Good morning. I'm Matt Nelson with ChemImage Corporation. I'm the chief scientist here. My background is in analytical chemistry. I've been with the company for 22 years. I head up our R&D applications group. Through the years, we've done a lot of development effort around hyperspectral imaging, the hardware, the software, the various tools, and applying these tools in real-world applications, including a number of venues like the Indy 500 and some NFL games, as well as the U.S. Open.
Thank you, Dr. Nelson. So before we start diving into some of the hyperspectral imaging facts, I wanted to get into kind of the overview of explosive detection capabilities and layered explosive detection. So first slide for us, we always wanted to make sure we're sharing resources. The intent of any of these forums is to give you some either artillery as you go back and start making some of those budgetary decisions or requests, or we wanted to at least give you information and knowledge and resources and tools that you can lean on in the future. We certainly don't want the conversations to stop here. So great resource that we certainly use anytime we're looking at explosive detection capabilities. The Office of Bombing Prevention and Department of Homeland Security puts out the Security and Resilience Guide. There is some specific aspects related to the sports leagues and venue stakeholders we encourage everyone to take a look at. We're operating under the assumption that we're looking at credible threats. Most of our venues have already been identified as soft targets. So a lot of what we're looking at are credible threats and how we're posturing ourselves to combat some of those threats. So within that guide we just looked at, there are 10 total goals, and there's 7 tasks with there's 7 tasks that venues or local law enforcement offices, public safety professionals are tasked with to carry out those goals. For today's session with hyperspectral imaging, most of our focus is going to be on 4 and 5, which are those site-specific preventative measures, protective measures, and screening procedures. And then lastly, before I get our speakers started, specifically as we talk about hyperspectral imaging, oh, I think you skipped on me there. Specifically on hyperspectral imaging, we're talking about within Goal 4 and Goal 5, we're looking at extending the security perimeter, additional vehicle screening, technology enhancements are all things that are mentioned in that resiliency guide. And hyperspectral imaging, we're applying to some of those areas. And within Goal 5, again, screening attendees, bags, looking at deliveries. But going back to Goal 1, Task 1, this is where we brought Sergeant Smith in. You can see right at the top of that list, one of the first things we want to do when we're looking at risks and we're looking at our local explosive detection capabilities is consulting some of the professionals within our communities. So in this case, without further ado, I'm going to go ahead and hand it to our resident bomb tech on the call with Sergeant Smith. Over to you.
Thank you, Daniel. See if it's going to click in now. There we go. So our first bit is safety, and that's paramount for us. So we look at a number of different factors, and first of all, everybody has is bomb dogs themselves. So we're going to look at canine utilization, some of the requirements that we have, and then how we're going to respond to it. And then some of the things that we'll have in our kit. And it's not everything that we have in our kit, but just some basics that we will have. And it's trace detection. And there's several different ones, some that are handheld, electronic swipe. And then others are what law enforcement would know as a wet chemical test, kind of like a drug test kit that you can use. It's pretty quick and effective. And then we get into our bread and butter is x-rays. But we're into a digital realm now. And it's much smaller, more portable, lightweight, and we can move around with it. And then we'll try to bring it all back together and then get into some Q&A if anybody has anything. So our first bit is we figure out our narrative, and it's usually going to be, besides safety, it's are we looking at unintended or a suspicious package? So we like to take our commander of our unit and get him out of our way, and then we push him up to the command post. And ultimately, he will actually go out and start teaching the people that we're going to want to talk to. And that's going to be the venue staff, public works if it's an open air event, and we're using any of their vehicles for blockades, entry control points, anything of that nature. And then we talk to law enforcement and firefighters, whoever's going to be on scene, and tell them this is what we want, this is what we're looking for. And if we can start driving that narrative, in turn, what they find, they can feed back to us, and we can already develop our response plan. So either the day of or before or up to the event, we're going to start briefing everybody, besides having an IAP that we can, or incident action plan that we can actually pass out to everybody, and then they can use as a reference. And then as bomb techs, we're going to have them start walking the venue and start learning where everything is, because at the time something happens, they don't need to look at where section 204 is and try to get there from the spot that they're at. And then on top of everything is how are we going to get in and out of that venue with our equipment, if we need to move fast and bring other people in, besides even getting to the device itself inside the venue. So it's a couple different things that we'll look at here. A little lag there. Daniel, I can't get it seem to go forward. Thank you. So again, we talk about safety first, and our basics for layered explosive is the canine teams. We like to have most of our handlers in this area are bomb techs as it is. And then we have additional bomb techs. For the handlers that aren't bomb techs, we assign a bomb tech to them. So as they're working their area of assignment, they can actually go forward with them, learn the venue, learn how to get in and out, and some of the obstacles that they may or may not have, as well as function check our equipment. One of the big things that we like to do is if we can get into the venue prior to, we bring all the dogs in and let them start working it and kind of get used to the environment. If not, that's where we rely on a certification process through NAPWADA, IPWADA, which is a National Association of Police Working Dogs, or International Association of Police Working Dogs, something that they have a basis and everybody has the same motor profiles that we know they can find. I mentioned that the bomb techs actually walk in the venue themselves with the dogs or without the dogs. A lot of times in seating, we have them go through and they can start seeing the obstacles in space they have to work when it comes to other equipment that we will deploy. And then ultimately, we're going to want to get right back to the area that we're all going to stage at to know where we're going to deploy from, break down into smaller groups, response groups, so to speak, and they will go off not so that not everybody runs to the same problem and we leave everything else unattended. And then we get back to the commander who's with the command post, and then we start handing the venues back over, whether it's incrementally or all at once, so they can start letting spectators and everybody else back inside. And I think I'm having the same problem again. So one of our first things that we have is trace detection. And it comes in two forms for us, both being electronic equipment and then the wet test kits that we talk about chemical wise. You'll see the four that are listed are ChemSpectral systems, the FIDO, the XD2, which is American Innovations, and the Sabre 5000. The ChemSpectral and the XD2 are powered swipe test. They require heat and then a separate chemical, and it's an application process. For us firefighters and cops, we have little lights, so it lets us know when to go to the next step so we don't mess it up. But the FIDO and the Sabre are both vapor detection, so you can actually walk around and move it from side to side on whatever you're trying to find out if it has been in touch with explosives. Then over on the right that we have the self-contained kits. It's the field forensics, EL 100, 200, and 300. Then we have Mistral Group's X-Pen, and then the Trace X, which is more of a one big self-contained test kit with multiple explosives that are on it. Oh, there we go. So I need to go back one. So some of the pros and cons of electronic equipment. It's accurate. It's real quick analysis time. Most of the delay in anything is the startup and heating up of the system. And then some of our swabs, if we can't get to our meter, we can actually hand it over if you're in an airport or a presidential event where TSA is there, they can hand them over to them and they can actually put it into their swipe machines and test it for you. And I say this, and some people may have issue with it, it's required gear for bomb techs. It is limited for us to bomb techs because we're the ones that have the equipment. The guys on the post don't normally have access to it. And that's where the con comes in, so they can't actually practice with it. So we just deal with it. And then again, when we get into cost, some of these meters are $2,000, some are $35,000, and they get really expensive. When it comes to the vapor detection ones, they require a lot of calibration, and sometimes they don't work well in harsh environments. We're around the ocean. Coast Guard has a big issue with it when it comes to that and boarding ships. And then if you've been overseas and you've tried to deploy it, SAN's not a big fan of it either. There is a shelf life to the chemicals that you use on the electronic ones. And then it's an updated cost yearly. And then if you get into peroxide-based explosives, that's an additional cost, which is much more than what the normal explosive shelf life is. And again, you have to have a power source with it. So with the self-contained kits, and this is what we run. We used to run the electronic kits. Now we've gone to the self-contained wet test kits. They're a lot more cost effective, and it still covers our requirement of being a requirement for our team to have. They're quick, easy to use. They come with pictures, so anybody can actually use them. And thanks to the military and the operations overseas, they've been refined and they're much more accurate. And they have a shelf life of up to about 3 years, which is great for us that we're not worried about changing out chemicals at $1,000 a pop each year. Some of the cons are they require multiple test kits. Some may have 2 explosives on this one, and the rest may have the ones that you want to test for. We've kind of learned how to adjust ours that way, so it's not a big deal for us, especially for the cost. Again, with both a swipe test on electronic and a self-contained kit, it's still proximity to your product that you're having to test or the device that you're dealing with. And again, we limit it to bomb tech deployment just because we're the ones that actually have the test kits. This is our bread and butter. It's digital X-ray systems. The one that we deploy is the Smart Ray Vision, not promoting either one. That just happened to be the one everybody voted on and picked. Scana has a great system that's out, and Logos has just as good a system as also. So none of them, two of them weren't even, the last one wasn't even in existence when we actually picked the Smart Ray. The image you see on the right-hand side is an actual image that we used on a plastic toolbox. We shot at very low pulses, and we're able to discern most every item that's inside of there. One of the cool things about this image is you can see everything in the top left, what it denotes, and then we can actually label each piece, and then we can start pushing it to the command post, and we can start pushing it to other team members, and we can start formulating plans as we go along. So pros and cons. Great thing about it is you can get more radiation from going outside in the sun than you can from shooting a low pulse X-ray with this system. It's very backpack compatible. We can actually hide it, the source and the panels and different items, and lay those down and X-ray our image, and nobody knows the wiser what we're doing, and compared to bulkier systems that you have to try to lug around and charge and get going. They're really easy to use. If you have a tablet, you can pretty much get by with it, so you don't have to be technology challenged to learn how to use it. Took us a couple hours and we were up and running. Quick image development, we've gotten as fast as 18 seconds, and some averages usually in the 90-second realm, so we do really well. Last piece I put in there is ruggedized. That's what they push. You're supposed to be able to pick your panels up and throw them from 3 to 6 foot in the air and drop on the ground, and nothing happened to them. But for $65,000 at the con on the right-hand side, that's not something I'm going to do regularly to test that out to see if they're true with it, because I can bang it around enough in a truck or just getting it to the device itself. And with that said, it's usually a budget grant item. That's how we got ours, because we had to have another phosphorus panels X-ray system to be able to actually be typed. So it was a luxury for us to be able to get the digital system. Again, you have to charge multiple pieces. You're charging panels, source batteries, cables. You have a bunch of different items that you have to actually bring everything together. So that is an issue also. And again, one of the X-ray systems was an actual adapted medical equipment, so you don't get a lot of your device. Some of the newer systems have come out, have been designed and had input by bomb techs, and you get more and more of the image as time has gone on and technology is developed. And then lastly, this is just venue specific. We're not talking about spectators. We're not talking about WMD devices or anything else. This is literally just about, as we like to put on our team, good customer service, get the basics down. It's safety, yes, but speed is a factor so that we don't delay anymore with the venue or getting it back open to the people or startling them any more than we have to. But that's all I have for this portion of mine. Thank you for your time.
All right, thank you. I'm gonna go ahead and click to the Q&A session here. So for the sake of time, we're probably gonna continue from here just to make sure we can make it through all the content. We have other question segments built in. We'll make sure that we get to questions as you ask them, and we'll fill those to the presenters before we wrap up here today. So again, as you can see, that the idea of the first part was to really get a feel for what your local community response agencies and bomb techs are able to bring to the fight, so to speak. So now what we're looking at is venue specific protective measures, some of the things that we have in conjunction with the walk-through metal detectors and other devices we're running at venues. We have Dr. Nelson and Dave here to speak to us about some other passive measures we can have in place, specifically hyperspectral imaging. So with that said, I'm going to go ahead and turn it over to Dr. Nelson.
Okay, thank you, Daniel. So just a quick rundown on the content for the rest of the presentation. I will be providing an overview of hyperspectral imaging, starting with some definitions around what it is. Briefly speak about a couple of different approaches that are out there to doing hyperspectral imaging and some of the trade-offs associated with those, and to talk a little bit more about some of the state of art and upcoming technology developments in this area. And then I'll field some question and answers, assuming we have time. And then I'll hand it off to my colleague, Dave, Cottle, who will be providing some perspectives from the practical applications of hyperspectral imaging, looking at fielded technologies and layered security approaches to using it. And then we'll wrap up with Q&A session. So hyperspectral imaging has a number of names that are used interchangeably. You'll also hear it called spectroscopic imaging or chemical imaging or molecular chemical imaging. All these things basically mean the same thing. What it is you're combining optical spectroscopy. Spectroscopy is a science in which you're studying how light interacts with matter. So whether that's an explosive chemical or a chemical warfare agent or any other type of material, it has a chemical signature associated with it. And when light interacts with it, that light can have different types of interactions depending on what the chemical makeup is. When you combine that with the digital imaging capability, then you have a way to actually visualize the chemistry that your sensor is viewing. So if you could imagine that you have a digital camera, which has a digital imaging capability within it, which is typically based on 3 color channels, red, green, and blue, you're able to capture an image of a scene and look at it on a pixel by basis and make an interpretation using your brain in terms of what you're seeing. Imagine adding another layer of information there where you're looking at the chemical-based information. So if I was looking for a particular type of chemistry, say I was looking for ANFO or TNT, I have the means of looking at the chemical signatures based on the way the light interacts with that material, and then to show in the image where there may be residues or bulk materials associated with those chemistries and where they are located. So that's what chemical imaging does. That's what hyperspectral imaging does for you. There are different types of techniques that are out there. Some are based on UV visible absorption or fluorescence or a scattering technique like Raman, which is a laser-based technique, or there are also near-infrared and mid-infrared absorption strategies. It all operates on parts of the electromagnetic spectrum. If you recall back to maybe a science course that you had in junior high or high school, you probably talked about the electromagnetic spectrum at some point. You're probably familiar with X-rays and microwaves and other parts of the spectrum. This chart just kind of shows the continuum of that electromagnetic spectrum and how you change from one part of the spectrum to another part of the spectrum is the differences in the wavelengths and the energies. Our eyes are able to see a part here that's pretty much in the middle, which we call the visible range, which runs from about 400 nanometers for the purplish or bluish colors out to about 800 nanometers or so for the redder colors. So the types of technologies that we'll be showcasing today in this talk will be predominantly operating in the shortwave infrared part of the spectrum, which is just beyond the red wavelengths that our eyes can see. So breaking down a little bit further in terms of the different types of spectral measurements that you're able to take. There are cameras out there that are black and white cameras that just provide an image in the format of a grayscale grayscale image in which the intensity of each pixel varies. There are also RGB cameras, like I mentioned, your phone camera is typically an RGB camera, which has 3 color channels. When you get beyond that, then you're starting to get into looking at more and more of the spectrum. So there are multispectral approaches, which typically correspond to 4 to 20 different spectral bands, or hyperspectral, in the case of what we're talking about now, is the 20 or more wavelength bands that you're characterizing. So there are different approaches to obtaining the data to provide the means for performing hyperspectral imaging. There are several here that I'll mention briefly. The simplest and historically the first one that was attempted was a point mapping approach. This is where you take a a measurement using a point approach, and that might be similar to what you would do with you know, a swab test or a FIDO, for instance, in which you're taking a measurement at a particular location. And then if you wanted to develop an image out of that, you would take multiple measurements at many, many spatial locations. As you can imagine, this would be very time consuming to do, because each time you take a measurement, it takes, you know, seconds or even longer in some cases, depending on what it is that you're measuring. Historically, then it progressed more to line scanning, which is a different type of approach in which you're getting more spatial information simultaneously. This is also known as push broom techniques, and those techniques are readily available for use for other applications that are out there. And then the wide field imaging approaches. These are the approaches that take an image at different frequencies or wavelengths, if you will, different colors, an image at a time, and then they tune through the different wave bands. So most of what we'll present here is in this category. This really has the advantage of being able to do things very quickly, and we'll talk briefly about some near real-time and real-time architectures for doing so. And the last category here is something that I won't really spend much time on. There are ways to get information where you're getting spatial and spectral information simultaneously using fiber optic arrays. And there are technologies that are available to do that. So moving on to one of these architectures, this is an example of a wide field imaging approach in which we're using something called liquid crystals. So if you have any of the modern televisions that use liquid crystals, you're probably somewhat familiar with it or may have heard of it. These devices contain some molecules in it. When you apply voltage to it, align in a way that you can change how the light is passing through it. So in other words, you can develop a device that allows you to tune to specific wave bands of light or different parts of the electromagnetic spectrum. And that's what this device does here in this particular illustration. It uses a number of these liquid crystal, what we call stages, and they're just little sandwiches of optical elements that control how the light is propagating through it. And then using the voltages applied to it, you can control, again, what part of the spectrum you're looking. And that can support near real-time architectures. When I say near real-time, I mean typically measurements on the order of seconds, less than 10 seconds. There are also up-and-coming real-time architectures. This is an example here where you're using a plurality or multiple liquid crystal filters in a configuration that allows you to take measurements at the speed in which the camera operates. And this is something that we've been developing recently, and it gets you into other regimes where your on-ops may be an instance where you're trying to look for crowd monitoring or vehicle that might be moving. So it can operate quick enough to make those kinds of measurements very quickly on the order of 10 times per second or greater than that. So a little bit more about how the measurement is taken. So once you take these architectures, whether it be a near real-time or real-time architecture, and make a sensor out of it, there are different types of spectroscopic strategies for extracting the chemical information from the scene. So this is an illustration here where we're using light. This light may be sunlight, or it could be used in combination with some incandescent lamps. You know, the types of lamps that you might go out and buy at a Home Depot. It has halogen lamps in them. The sensor you see here has a series of halogen lamps around the front part of the sensor. And what you then do is you illuminate your area that you're going to image. In this case, for the cartoon, we have a little vehicle that has a handprint on it, which is simulating somebody that may have touched explosives and then touched the vehicle and transferred some of that material to the vehicle. And so the way that this sensor would then work is we would tune to the frequencies or the colors of light that are characteristic of chemistries of the explosive materials that we're looking for. So in other words, if we were looking for C4, we would tune to a C4 wavelength, or if we were looking for TNT or ANFO, we would tune that device to those frequencies. As you do that, you build up more and more spectral information that can be searched against a library of signatures, and then that will tell you whether you have a spectral match with the library to give you an indication of whether you have an explosive material or not. And it does this for every single pixel in the image. So ultimately, what you'll see in some of the upcoming slides that Dave will brief is some examples of those where we do have the overlay images showing the spatial locations of where those explosive residues are residing in the imagery that we look at. Daniel, I'll hand it back to you for questions.
Yes, sir. Thank you, Dr. Nelson. First question is, what degree of accuracy are we able to get with hyperspectral imaging?
It's a fantastic question. Usually I think of accuracy in two parts. There's the probability of detecting something or what our sensitivity is, and the probability of false alarming or related to the selectivity. So a lot of these technologies, depending on the application and the use scenarios, we'll typically get sensitivities that are on the order of 90% or greater, and selectivities that are equally as good. So our false alarm rates are relatively low in the single digits.
Great. And the next question is, are you able to build your library of what you might be pulling from the spectrum? Assuming you have local contaminants, chemicals. I know we all operate in different areas where you might have chemical manufacturers that produce different mixtures of solutions. Can you program hyperspectral to identify that specific solution, in turn identifying where it might be coming from?
Yeah, absolutely. And we have done work in the past where we've looked at a variety of explosive materials and different types of HME materials where they've mixed different things together in it. Typically, what we will be primarily interested in for the applications that we've worked with is understanding what, if you have an ammonium nitrate based HME, for instance, you'd be really interested looking at the signature for the ammonium nitrate itself. So whether it's pure ammonium nitrate or ANFO mixed with some other ingredients, ultimately we're looking to kind of pinpoint on that ammonium nitrate signature to give you the first indication that you have an explosive or not for that category of explosive. We do have the ability to then take a sort of a secondary measurement where you're taking more spectral measurements at other wavelengths. This takes a little bit longer, so this kind of knocks you out of the real-time regime or the near real-time regime. And on the order of maybe a minute or two, you're able to get more spectral information that can give you even more selectivity to the extent that you may be able to differentiate things like where the origin of the material was coming from. We don't have an expansive library to do that, but we do have the capabilities with the equipment to allow the users to develop those kinds of libraries.
And the Dave's portion on the follow-up, because I know he's going to speak toward kind of operationalizing some of the technology. But the question is, I mean, we have commercial deliveries, a lot of those things coming in and out of venues. So when we're looking at something with the footprint of an 18-wheeler per se, you showed one of the devices, a camera with the lights around it, being able to get a good view. How many cameras would you need for an 18-wheeler to be able to pass through and get an accurate snapshot? Or is this something where you would want to stop them with the technology and do a walk around of the vehicle?
Right, great question. So there's some trade-offs here to consider depending on the nature of the, if you're doing an entry control point kind of application. The closer you are to between the sensor and the vehicle, the more sensitivity you have. So if you're really looking for those low amounts of materials, you're going to have a better chance of making a detection if you're closer in. So in those instances, what we recommend is you kind of key in on specific locations of the vehicle that might be apt to having a higher frequency of an exchange of material. So that would be where people are getting in and out of the vehicle. That might be your gas tank, that might be the trunk area, that might be the opening to the doors on the back of an 18-wheeler. You can move the sensor back, but when you're doing that, again, you're trading off that sensitivity. And so, you know, instead of looking at microgram quantity, low microgram quantities, you might be now looking for something that would be more on the bulk level, like a spill in the rear of the vehicle.
Great. And seeing that we are doing well on time, I do have one question I'm gonna throw to Sergeant Smith now. Which was how are you interfacing with the venue personnel or the staff? You mentioned some of the work with anything from fixed facility and events such as Super Bowls to some of the PGA work you all are doing. Now, I'm assuming that your organization, you're not operating autonomously from the rest of the organization. So if there's any indication from the venue, how are you interfacing with those individuals to get those notifications, but also to supplement what they're doing locally?
So we actually have somebody assigned, usually our lieutenant, that's assigned to the command group or to the venue staff, so that they all come together and get all the information at the same time. And he also in turn will be the one that will go out and speak to each group so they know his face and who they're speaking to and understand the narrative that we have that we're trying to drive. But ultimately we are with the event staff, wherever that one core group that can make decisions, we have our guy there with, so that they can translate what we're trying to accomplish.
Fantastic. And I do have a couple questions. I got one from one of our old friends, Dan. I'll get to that on the back end, Dan. But for now, I want to go ahead and make sure we're keeping pace. So Dave, I'm going to hand it over to you so you can cover your piece and we'll get to the rest of those questions. As a reminder, if you have any questions, please feel free to post those at any point. You can use that menu on your right, select questions. We aren't using the hand raise function, so please feel free again to post those questions anytime you have them, and we'll make sure we field those. And if we don't get to them during the discussion today, we'll try to follow up with you as soon as we can. All right, thank you. Over to you, Dave.
Thank you, Daniel. Okay, so applied chemical imaging. Matt explained the science. Let me briefly touch on some of its applications. Chemical imaging, as you can imagine, has many applications. Our business has found it to be a great fit in these three areas. On the left, finding drugs and other illicit substances concealed in mail items, primarily for the corrections industry. On the right, biomedical and life sciences applications, such as assisting in the visualization for surgeries and surgeons. And in the middle there, most applicably to today's topic, the detection of chemical and explosive threats. Okay, so using chemical imaging to look for evidence indicating the presence of an explosive device is a relatively new concept to venue security. However, it's not new to the United States military. In the global war on terror, we set up these combat outposts all over the Middle East. And these outposts all have entry control points. Vehicles, cargo, people, they all have to come in and out. And obviously these combat outposts are or were potential targets by our adversaries. We had a particular problem with vehicle-borne improvised explosive devices. And the U.S. military invested in a lot of potential technology solutions to this problem. One of the areas where they found success was in shortwave infrared standoff imaging. So at these comps, we were controlling the traffic. Each vehicle is pausing briefly, getting scanned by the shortwave infrared sensor, and the operator, who is well removed from the vehicle in the blast radius, is seeing this image that you see on the right. This grayscale image with a false color overlay highlighting potential explosives or explosive precursors. So it's not hard to see the value here. The contamination on the exterior of this container likely matches the contents of that container. So not only are you getting a detection, but you're also getting a specific location in the scene of where the contamination exists. Okay, so how does this translate to event security? So that sensor that I just showed you, that was a really big, heavy, militarized sensor. Probably cost prohibitive for a lot of civilian uses, but as with any successful technology, Evolution and economies of scale have made this system a size and a cost much more appropriate for use in the security community. The concept is the same. You structure the traffic, as you can see on the bottom left here. You scan each vehicle for indicators of explosives. And on the right, you can see just an example of what that looks like on a venue security mission featuring our sensors at the US Open last year. Simple ECP, scan every vehicle as it comes in, looking for those evidence of explosives and explosive precursors. Okay, so this is the type of evidence that we're looking for. As Matt stated, there are a few different ways to use this technology. You can attempt to look at the entire vehicle, or you can look at potential sort of hotspots of concentration where we typically see higher amounts or higher concentrations of explosives or explosive precursor residue. You can imagine if you touch explosive material and then touch the vehicle, if you transfer explosive material to the outside of that vehicle, the likely spots, door handles, trunk doors, those parts of the vehicle you interact with. So you can really dial that sensor into those locations. You can structure your ECP to force that vehicle to present that portion of the target to the sensor, and which really makes the system run smoothly and semi-autonomously with less and less needed user involvement. But in this case, at the US Open, fortunately, nobody tried to get a large explosive device in the US Open last year. So as always, we want to test our system in partnership with local law enforcement. In this case, the local law enforcement partners ensure that our technology was working as it should by putting a very small amount of explosive residue on the door handle. And as you can see on the right, that's what the user sees, and we didn't, in fact, make that true positive detection. All right, the Harvey Balls chart. So we're talking layered approach as the theme today. What do we typically recommend? We have military and we have law enforcement contacts that trust us, and they will ask us, hey, we have a problem, or we have a credible threat, or we're building a world-class entry control point. What do you recommend? And the first thing that we always say is, look, there is no silver bullet, including our own technologies. All of these tactics, all of these technologies have a role to play. All of them have their limitations. This chart is sort of the way that we depict that each of these technologies really shore up the limitations of the other technologies. So what we typically recommend is a well thought out, layered approach that takes advantages of all the strengths that you can see on this chart. So integration, talking about a new technology that's not historically been used in venue security, or has only just started to become used in venue security. How do we integrate this into the layer security that we're already using in our venues? So my recommendation would be, and usually is, start by extending your perimeter. You've got this highly portable sensor. Get it outside of your other tactics to meet the potential threat as early as humanly possible. So separate your security professionals, separate your working dogs, separate the population from that potential threat, and let's get eyes on it. Let's screen it as early as humanly possible and extend our perimeter, especially for vehicle-borne IEDs, given the devastation, the amount of explosive material you can pack in the vehicle. Don't forgo the other technologies and the other tactics. Use the optical sensors to queue them up and to target the other tactics that you have in your toolkit, whatever those may be. The chemical imaging sensor, keep in mind, is telling you that you potentially have a problem. It's making a detection, but also keep in mind it's telling you where, which can be very helpful in targeting some of the other sensing modalities that you all have at your disposal. Okay, so this technology to sort of expand the perimeter that's really focused on and was derived from military technologies to combat vehicle-borne explosive devices. That's available today. There is other applications for it, left behind baggage and that sort of thing. But at its core, this is really a vehicle screening device or sensor. But I would be remiss if I didn't also tell you we have some really interesting developments, technology developments in the pipeline as well, as the result of other military projects. So be on the lookout for some real-time sensors that could perform those same types of screening functions, but say real-time, unstructured crowds, The example at the bottom here is a technology that's been funded by the Defense Advanced Research Projects Agency, DARPA. And this is the same sort of sensing architecture, but what it's looking for is this same explosive evidence on the outside of a backpack or of a human being, which would open us up to sort of unstructured crowd monitoring applications, which is exciting. So in conclusion for my section, venue security really benefits from a total layered security approach. There is no single silver bullet. Explosive detection, especially when it comes to vehicles, is a very challenging problem that we've faced in the United States military for many, many years. And there's no one technology that can meet the need. However, hyperspectral imaging is becoming is increasingly important element of that overall security solution, of that overall security picture. And with that, I'll turn it back over to Daniel.
All right, thank you, Dave. So first question I'm going to ask, you had mentioned, well, I'll get back to Dan's question first. I know last break he'd asked, what's the rate of false positives or negative results? I know anytime, for me, having a background in kind of the CBRN WMD detection world, we would get false positives. We had to be mindful of anything from bug sprays to detergents to colognes could always cause something to go off, an alarm to be set off. So in this case, when we're looking at this technology, what types of false positive concerns do we have to have, if any?
Sure. Matt, do you want to take that one, or would you like me to?
Sure, I can. So I think I mentioned before, some of the, let me break down the false alarm thing a little bit greater detail than what I did before. So typically what you'll see with the types of algorithms and software that are working behind the scene here, underneath the hood, if you will, you know, they have some automated capabilities. They're not perfect. A lot of times the human can take a look at the results that you're getting and to make an interpretation of it better than a computer algorithm can at this point in time. So typically the software will come back with false alarm rates that are usually in the single digits. A lot of those false alarms that you see then can be interpreted by the human as being false. There may be particular plastics on the car, for instance, that may get mixed up with the plasticizers that are in some of the explosives. And when you see that, what you'll end up having is a detection of that plastic device that's on the vehicle itself, and it'll encompass the entire thing. So when you look at that, you say, well, if somebody's transferring residue to that plastic cover on the headlight, for instance, they're not covering the entire headlight. They would more likely be transmitting something in the form of a fingerprint transfer. So the operator can typically dismiss that as a false alarm. If they're concerned that it may be real, there are some downstream CONOPS that we can follow, or procedures that we can follow to further reduce the probability that it is a false alarm, such as taking another look at the same field of view by zooming in a little bit. When you zoom in, you do increase that sensitivity to what you're looking at. And you can also collect more of the hypercube, or more spectral channels, if you will, to get a more definitive match to what is in the library. So there's those kinds of trade-offs that you can deal with. Also, working in conjunction with other technologies also allows you to then drive down that overall false alarm rate.
Fantastic. And just had a question pop up, and it's fortuitous, and I'll explain why here in a moment. But first, I think this one's probably Dave and Sergeant Smith, one of you. Are there any grants available to assist with the cost of equipment such as this that you're aware of?
Robert?
Go ahead, Dave.
No,
we
please.
have, so some of, for us, we have a luxury of having a port security grant, and then sometimes there's a Homeland Security grant, so that might be able to benefit in this, especially now. The big narrative with the Bureau on our side is maritime and stabilization, which being in your world of WMD, Daniel, and that sort of thing. So there are grants that are out there that can actually cover that.
Yeah. Just to echo that, I'm not sure who asked the question, the specific circumstances, but we can typically work with we at least work with our customers to attempt to seek out grant funding, and have had quite a bit of success with that in the past.
And I'll say grants a lot of times are fairly fluid and reactionary to a lot of what's going on. So I've seen some come and go. Hopefully in the near future, we're actually planning on discussing some of those grant funding opportunities and how we can leverage various legislature and grants to help offset some of the costs of technologies and tool sets that can ultimately help bolster our safety and security procedures and measures locally. So hopefully in the near future, in the coming month or two, we're able to put a good online forum together where we can really discuss those things. So the next question, I know we're a lot of the focus here is pushing that perimeter out, and we spend a lot of time on that with the various venues across the country and how we can extend that perimeter. We can get early warnings and detection. We can warn people sooner, and in this case, even guide our explosive detection canines and capabilities to potential threats. Now, with this, one of the questions that was asked was how long does each vehicle have to stop for to get a scanning? The number thrown out was 10 seconds. So is there a 10-second window for the analysis to take place?
That's correct. 10 seconds, and 10 seconds is on the long end. I think on the average, it's probably more like 8 or so. But yes, that vehicle does have to be, that vehicle does need to be still for roughly 10 seconds or so. With a technology like this, with any optical technology, controlling as many environmental factors as humanly possible, it gives you a higher probability of detection and a lower probability of false alarm. So if you can control the environmental factors, keep the lighting relatively from changing, keep the vehicle from moving, you're going to get the best probability of detection and the best probability of false alarm.
Great. You mentioned false alarm again. I know someone had mentioned false positives. I know a lot of that is done. A lot of this is done, and this is just from me to the crowd. We leverage new equipment training for a lot of the detection capabilities we build. These are the things that most of the solution providers offer up. Whenever you're looking at the technology coming out, helping you understand how it deploys. Very few technologies are immune to false positives, whether it's a canine or some type of meter you might be swinging. I've seen canines hit on hot dogs and potential other potential devices. I've seen other technologies give false indications. Again, bug sprays, various environmental factors can influence those. So a lot of that is accomplished in that again, new purchase training coming onto the site and getting that initial education from the solution providers. And Dave, maybe you can speak toward programs that are in place generally to help educate the end user on the technology.
Sure, of course. To sort of bring what you were saying and what Dr. Nelson was saying earlier together, the interesting thing about this technology and combating false alarms that exist in any technology is there's a logic to the user combating false alarms here, right? Because they're looking at an image. They're not seeing, a dog sit or a readout from a computer. They're looking at an image, and then they're applying their own logic to that image. If the alarm is in a part of the scene that does not make sense, why it would alarm there, which is usually the case, and that user can just apply a pathologic to that and go, that's probably not a real detection. So I think that's part of the way that we answer that false alarm detection. And that training is not complicated. And so you're asking me to comment on the training portion of this. Obviously, when we deploy these detection technologies with the United States military, we send a training package with that to work with the user community to get them up to speed on not just how the technology works, but how to employ it most effectively. We do the same now in the civilian world. So oftentimes we're asked to do venue security and come personally and operate the equipment. Oftentimes we'll be asked to hard install sensors and leave them there and train everybody that may touch or interact with that sensor. But at the end of the day, it's really not hard. I think Matt can correct me if I'm wrong. I think our standard training package is about 1 day or so, unless you want to have the ability to add those local flavors. Our international customers, for example, unless you want to get to the point where you can identify a new threat that exists specifically in your community or in your country, and then add that to the library, the training for operating the sensor is a day, and then getting to the level of expertise of expanding the library is a few days.
Absolutely. And I know we're starting to get closer to the end of time. I did have one more question. Before I get into the question, I did want to go ahead and say, for my canine handler pals out there, before they attack me, I have not seen a dog false alarm on a hot dog. I've seen them get distracted by a hot dog. So just to clarify that, I've seen them false alarm on something out of habit that they think they'll get that ball. So for clarity purposes, don't come at me just yet. So the next question here is, it says, do you see hyperspectral analysis replacing other capabilities in the future? Again, I think most of the discussion here is about supplementing existing technologies. Specifically, it's focused on ETD. It says identifies the substance currently. Can Spectral get to that point rather than just showing a color and become an option for TSA, was one of the specifics here.
Matt, do you mind if I give the short version, and then I'll let you give the technical answer there?
Go ahead, sure.
I don't look, as computers get better, as the processors get faster, as this technology generally matures, it's going to get a lot better. It'll get more passive. Its capabilities for identification, not just detection, will improve. However, I don't see it replacing some of the key components to your layered security approach. I see it as supplementing, and I see the next generation of this as highly autonomous, where it's hard installed or set up temporarily for an event, and then it's largely left alone, and a truly autonomous alarm notifies you if you have a problem, where you don't have to commit personnel resources to operating these sensors. That's where I see this technology going, is continue to supplement without overcommitting your resources, but probably not replacing some of your very sensitive tools that you have in your toolkit. Matt?
Yeah, I think you hit the nail on the head there, Dave. I really don't have much to add other than that's just it. All these technological developments will improve over time, including the hyperspectral imaging. Sensitivities will get better, selectivities will get better, but ultimately, I think each is going to have advantages, disadvantages, capabilities, limitations. And when you layer these things, the information that you're getting is independent of the other, and it provides an overall solution that's better than any individual component alone.
Fantastic. Now, Sergeant Smith, before we start slowing down, did you have anything else to add to the discussion so far?
No. If I can ever be a help to anybody, please just reach out. But no, I think it's great.
Fantastic. And the goal of these discussions, again, we're trying to explore various technologies. We talk about having, again, today it was focused on an additional layer that we could add to explosive detection. But what we're doing through the online technology series is looking at the various tools in the toolbox, so to speak. What technologies are out there, and how can we apply them into an operational setting? So certainly, any closing remarks by any of you before we start shutting down for this morning? Nope.
I would like to just take the opportunity to say to this community, thank you very much for keeping us safe while we enjoy our concerts and sporting events. It's a very challenging mission. Thank you.
And absolutely, I'd like to echo that as well. Thank you for your attention this morning. It was a great opportunity to speak a little bit about our technology, and if folks have questions in the future, reach out. Be happy to help. Thank you again.
Again, everyone, thank you all so much for your time. Thanks for entrusting us with a little bit of your time this Thursday. We hope to see you all in the near future and discuss other technologies that we can apply to various problems and gaps at venues. So again, thank you. You guys have a great rest of the week and into your weekend. Have a good day.